This is a question from 2001. A technician is asked to construct a potential divider circuit to deliver an output voltage of 1.2 volts using a battery of EMF 3 volts and internal negligible resistance. To conserve the life of the battery, it is desirable that the current drawn from it should be about 10 microamps. Draw a diagram of the circuit in which the current drawn from the battery is 10 microamps. Calculate the values of any resistors used. Show where the terminals should be made to obtain the 1.2 volt output and label the output terms T1, T plus and T minus to indicate their polarity. So we're just going to draw a wee potential divider circuit first of all. And so it doesn't really matter where you put your battery. So you've got two resistors, R1 and R2, or you can label them the other way around, it's up to you. And we want to deliver an output voltage of 1.2 volts, so I'm going to take that off here. So there's our V out equals 1.2, and then our EMF, which is delivering the voltage, is 3 volts. We have got a current of 10 microamps that goes this direction, and therefore if we're labelling pluses and minus on our potential divider output, then this one here is a plus terminal and this one is a minus terminal. Calculate the values of any resistors used. So we know what the ratio of the voltage is. If that's 1.2 volts, then this is going to be 3 minus 1.2, which is 1.8. And therefore the ratio of the resistors is R1 to R2 is 1.8 to 1.2. And so you can see there that you have got a ratio of 18 to 12, or if you divide by 2 then it's 9 to 6, or even divide by 3 then you get 3 to 2. Now that still doesn't give us enough information, so we're going to have to use the current to calculate the total resistance in the circuit. So the total resistance in the circuit is going to be V over I, which is total voltage or EMF of 3 divided by 10 microamps. And that is going to give us a total resistance of 3 by 10 to the 5 ohms. And so we have to divide our two ratios then, 3 to 2. So if we do that, then R1 comes out to be 3/5 of that, which is 1.8 by 10 to the 5 ohms. And R2 comes out to be 2/5 of that, there's the ratio 2/5, which is 1.2 by 10 to the 5 ohms. And you can label those in there as you're supposed to in part 1. So part 2, we now have got, I'll just redraw this really quickly. R1, in fact we'll put the values onto it. We've now got a voltmeter in here. It's got a 1 kilo ohm value. We have got this one here was R1, it was 1.8 by 10 to the 5. And this one here is 1.2 by 10 to the 5. Okay, so this is now connected across in parallel, and it asks you to calculate how the output voltage and current are affected and then determine the new values. So when you add this in parallel, that reduces the resistance here. And that means since you've still 3 volts available, R1 is going to get more voltage, but R2 is going to be less. So this will reduce, V out is reduced. But if you lower the resistance in the whole circuit, that means that the overall current increases, and so I is increased. Okay, and we're going to calculate those values then. So the first thing I'm going to do is calculate the total parallel resistance of this part here. And so the total resistance here is going to be, I'll do the product of the sum, 1.2 by 10 to the 5 by 1 by 10 to the 3 over 1.2 by 10 to the 5 by 1, adding plus 1 by 10 to the 3. And that comes out then to be 0.99 kilo ohms. So it's, remember, if you remember, the answer is always less than the smallest resistor that's there in parallel. So you've got a 1 kilo ohm resistor in parallel. And now we can find the current. So the current in the circuit using the total EMF, which is 3, divided by the total resistance is 0.99 by 10 to the 3 plus 1.8 by 10 to the 5. And that comes out as 16.6 milliamps. And then we're going to calculate the voltage in the parallel bit, which is our output voltage. V out is 16.6 by 10 to the minus 3 times the total resistance in this bit, which is 0.99 by 10 to the 3. And that gives you an output voltage of 0.016 volts. Okay, and that's all you have to do. There's your two new values.